All right, the basics of quantum chemistry is to understand the electron configuration. And understanding the electron configuration requires us to know the s orbitals and the p orbitals, the d orbitals, and the f orbitals. And we understand these orbitals, we will go into finding the quantum chemistry. And then after finding the quantum chemistry, what do we have to do to find the hybridization? Well, let's understand the concept. So let's think out of the box, not in the box. Understand the Bohr model. Bohr model, thanks to Bohr model. Understand the Bohr model. If we go down, all right, so if we move down, what will happen? The energy sublevels will increase. And what will happen if the energy sublevels increase? That means the radius will increase. What will happen if the radius increase? That means the electrons will increase. All right. We need to understand we also need to understand the idea behind orbitals. What is orbital? Well, we know that the highest s orbital can handle is basically 2 electrons. The highest number of electrons the s orbital can handle is 2 electrons. The highest number of electrons that the d orbital can handle is basically 10 electrons. The highest number of electrons that p orbital can handle is basically 6 electrons. And the highest the electron number that the f orbital can handle is basically 14 electrons. Well, why we say it's 14 electrons? Well, think about it. Think about the valence electron. Think about many things. All right. If we go down the alkali metal, all right, and we try to find hydrogen, we put just one s. Well, one indicates that what? Well, 1 indicates that it contains 1 electron. All right. Well, that's not the idea that we're trying to check. Well, how do we understand the electron configuration? Well, here the electron configuration, there is 2 forms. There's a condensed form and there's a long form. They usually ask about the condensed form. If you take any exam, they usually aim for the condensed form. All right. The long form is easier to go. You just go down the periodic table, but they want the condensed form because it's easier to find and it's easier to trick. All right. Well, let's just go ahead and drop us into the game. Well, let's do it then. If we're trying to find the helium, what do we put? Well, if we're trying to find the helium, it's basically just 1s2. All right. Why 1s2? Because 1s1 is basically hydrogen, and 1s2, because 1 indicates the energy level, it's basically helium. All right. Well, what's the condensed form of neon, for example? Wait a minute. What's the condensed form of neon? Well, we can just write it as helium 2s2 2p6. All right. Why do we write this and not include the 1s1? Well, we write this and not include the 1s1 because it's a condensed form. That means we just go straight ahead to the noble gases and we pick which one end in the last, the last column. So basically, if we're trying to find neon, we need to find. So if we're trying to find neon, then the one on the bracket is going to be helium. If we're trying to find the argon, then the one in the bracket is going to be neon. If we're trying to find bromine, then the one on the bracket is going to be argon. If we're trying to find iodine, and the one in the bracket is going to be krypton. If we're trying to find our radon, for example, the one in the bracket is going to be xenon. All right. If we're trying to find manganese, and then the one on the bracket going to be radon. So just understand the condensed form. Do not understand the long form, because the long form we just go straight ahead. So the long form of neon, for example, if we're trying to find the long form of neon, it the long form of neon. Sorry for that. It would be no, the long form neon. We don't need any bracket. The long form neon would be 1s2, 2s2, 2p6, no bracket. But putting the bracket, such as like helium for neon, it's basically telling us that, hey, we're trying to find the configuration after helium. So when we put bracket into helium, that means we go straight ahead to 2s2 and 2p6. If you put bracket into neon, that means we go into 3s2 and 3p6. All right. So just understanding the concept behind the periodic table will help you a lot in finding the electron configuration. Let's pick a little hard one. So we need to find gold. We need to find the electron configuration of gold. Oh no. Let's just do not pick a hard one. I'm doing the hard one on part 2. So let's just find the electron configuration of silver. So not the long form. The long form will take a lot of time. Let's find the condensed form of silver. Well, the condensed form of silver is basically krypton, because that's the noble gas that comes right before silver. So, and then we go straight ahead to 1, 2, 3, 4, and 5. All right. So we go to 5. Yeah, 1, 2, 3, 4, 5. So we go to 5, S2, and then after going to 5s2, we go to 4d. After finding the 5s2, we go to 4d. We'll just go straight ahead to this. Yes, that's basically what we need. But just put D. Do not put P if you're doing condensed form. So 5s to 4d9, because silver is right here. Right. So yeah, 5s to 4d9. That's it. Done. And I hope that